From static proof to dynamic discovery. The journey of a current loop. The derivation sheet serves as the intellectual blueprint for a journey that transforms abstract mathematical truths into a vivid, interactive exploration of physical reality. While the original derivation focuses on calculating results, the sequence and state diagrams map out how those results evolve from simple drawings into a sophisticated simulation of nature. The logic of the sequence. From theory to motion. The sequence diagram mirrors the logical progression of the derivation sheet by first establishing a fundamental baseline. In a perfectly uniform magnetic field, a current loop experiences no net translational pull. It captures the transition from this zero-force mathematical proof to the introduction of rotational dynamics. Instead of just calculating a result on paper, the sequence logic introduces physical properties like inertia, allowing the loop to actually move and seek a state of balance. This diagram further details the transition into user agency, where the static equations of the derivation sheet are handed over to the viewer. By incorporating sliders and buttons, the sequence ensures that the mathematical relationship between the field and the loop is no longer a fixed answer but a dynamic discovery made through real-time interaction. The evolution of the state. From effect to cause. The state diagram categorizes the conceptual growth of the project, moving through stages of increasing depth that reflect the derivation's core insights. It marks the shift from abstract observation, simply seeing a torque arrow, to physical manifestation, where the loop physically twists toward the magnetic field to minimize its stored energy. A critical state in this evolution is the transition from effect to cause. While the math focuses on the resulting magnetic moment, the diagrams emphasize the current flow as the underlying reason for that moment's existence, using visual cues to reinforce the physical connection known as the right-hand rule. Finally, the state diagram reaches the ultimate conceptual contrast found in the derivation, the distinction between twisting and moving. By shifting the state from a uniform to a non-uniform field, the simulation provides a visual proof that while a loop in a steady field only rotates, a loop in a varying field is physically pushed through space. The essence. Seeking equilibrium. At its heart, the narrative shared by these diagrams and the derivation is the story of a system seeking minimum potential energy. Whether it is the sequence showing the steps to calculate the state or the state diagram showing the different modes of physical behavior, the essence remains the same. A current loop is a dynamic object that responds to its environment by aligning itself with the invisible lines of a magnetic field.